How far do you think a modern probe can travel into space in 44 years? What will it observe beyond Earth, and what dangers might it face? We know the answer to the first question for sure. At this stage, the unmanned spacecraft, created at the end of the last century, can travel about 11 billion miles in less than half a century. That's an unimaginable distance by Earth standards. Voyager 2 proved this after traveling through the darkness of the universe for years, and you won't believe how many mysteries the little space scout uncovered during its journey. Equipped with a multitude of scientific research instruments, Voyager 2 gave astronomers a detailed account of its heroic route, charted through hardships toward distant stars. Where should we start? Probably with the data collected by the probe within the solar system. But what about high-tech telescopes, you might ask? They've long observed neighboring planets and consistently sent useful information about them. Yes, but their work can't compare to that of a probe that's in close proximity to a celestial body. In the second case, the information is far more informative. So, where did the Voyager 2 mission launch from? It started from the giant Jupiter, which, if it wanted to, could swallow all the planets of the solar system. Of course, we already knew that our planetary system consists of rocky objects of the terrestrial group and gas giants. And we were also aware of Saturn's icy rings and Jupiter's global hurricanes. But these were just fragments of information, and Voyager 2, along with its curious twin brother, set out to fill in the gaps. Jupiter. Voyager 2 began sending images of Jupiter to Earth on April 24, 1979. The initial images highlighted the gas giant's stormy atmosphere. Astronomers used the photo series to make a short film and gain insights into atmospheric circulation. Unlike Voyager 1, the second probe came very close to Jupiter's moons, Io and Europa, capturing the period of their close approach. As a result, we obtained amazing images of Jupiter's vast system, including a clear picture of its moon, Callisto, as well as Ganymede, Europa, and Io, and Amalthea. At its closest point to Jupiter, Voyager 2 was on July 9, 1979, at a distance of 4,785 miles. From this location, the probe transmitted updated data regarding the planet's clouds. 4 moons and the ring system were rediscovered, and 17,000 new images were obtained, combined from the cameras of both Voyagers. At least 80% of the surfaces of Ganymede and Callisto, as well as Saturn, were mapped by astronomers. As a result, Voyager 2 in some ways repeated the photographic mission of its predecessor, surpassing it at Saturn. The probe's encounter with the 6th planet of the solar system took place on August 22, 1981, 2 years after the spacecraft left Jupiter, and sent the first image of Saturn's moon Iapetus to Earth. When Voyager 2 flew past Saturn, it was confirmed that the thickness of its rings is about 980 feet. But this is a very averaged value, since in some places this parameter reaches only 10/100 meters. During its time near the planet, the probe passed through Saturn's rings at a speed of 8 miles per hour. This happened very quickly, within a few seconds. During the risky maneuver, myriads of dust particles simultaneously struck the metal body of the spacecraft, leaving plasma trails behind. Voyager 2 also captured Saturn's moons Hyperion and Saturn, Enceladus, Tethys, Phoebe, and the recently discovered Hellendelist and Calypso Uranus. The 2 main tasks were finished and retirement seemed near, but the scientists chose differently. The developers sent the veteran spacecraft to Uranus, which then made a flight to Neptune possible. But before that, Voyager 2 spent 5.5 hours carefully studying the ghostly and distant Uranus. The probe became a pioneer spacecraft created by human hands that flew past this planet. Detailed observations of Uranus began on November 4, 1985. The first signals from the probe reached Earth in about 2.5 hours. What difficulties did Voyager 2 encounter while studying this celestial body? The most significant problem was the lack of light. The icy planet receives 400 times less light than Earth. The closest approach to Uranus occurred on January 24, 1986, at a distance of about 50,640 miles. What remarkable discoveries did Voyager 2 make in this location? The probe discovered 10 new moons, which were named after characters from Shakespearean tragedies. Bach, Portia, Juliet, Rosalind, Belinda, Desdemona, Cordelia, Ophelia, and Bianca. He found 2 new rings in addition to the 9 already known, and detected a magnetic field tilted at 55 degrees and slightly offset. Centro. Voyager 2 also captured striking photos of Uranus's large moons. After its encounter with the planet on February 14, 1986, the spacecraft performed its only gravity assist maneuver halfway through its journey, the largest and most significant ever conducted. Voyager 2 needed this to chart a course to Neptune. The probe approached Neptune on August 25, 1989. To do this, Voyager 2 traveled about 9,980 miles, flying over the clouds of the giant planets, coming closest during the 4 flybys it made as it approached them. Meanwhile, the spacecraft continued its diligent work. For example, it discovered 6 new moons and 4 rings. Neptune itself turned out to be a real box of surprises. In particular, it turned out that its surface is far from calm. There are constant hellish winds blowing at speeds of about 60 miles or 110 kilometers per hour. And that's the lowest figure, because the speed of atmospheric currents in some of Neptune's persistent storms is the highest in the solar system, reaching up to 2,400 kilometers per hour. Did the probe manage to learn anything about Neptune's atmosphere? The instruments showed that the most common element is hydrogen, although methane was also present in the atmosphere, giving Neptune its nice blue tint. The images clearly show 3 huge structures, presumably hurricanes: the Great Dark Spot, the Small Dark Spot, and the Scooter. Voyager 2 also captured 2/3 of Neptune's largest moon, Triton, the coldest known body in the solar system, and a cryovolcano spewing nitrogen onto the planet's surface. The stunning images of Neptune's southern hemisphere showed space agency observers a strange terrain with a surface that resembles a bearded melon. Voyager 2's mission ended triumphantly with a flyby of Neptune. It is worth noting that after studying the distant planet, the probe continued to function fully for many more years. In 2011, after a command from the control center, it switched to alternative thrusters for the navigation system. And in 2019, National Aeronautics and Space Administration announced that it had received data from the interstellar medium transmitted by the spacecraft, where Voyager 2 was headed. Next, after visiting Neptune, the probe followed a course below the plane of the ecliptic for some time and left the solar system at a distance of about 35 million miles from its launch point. After the encounter with Neptune, many of Voyager 2's instruments were switched to low-power mode to conserve energy. It is noteworthy that 12 years after launch, in November 1989, National Aeronautics and Space Administration officially renamed the project, giving it the more grandiose title of Voyager Interstellar Mission Spacecraft. Instruments of secondary importance were permanently deactivated, and only 7 scientific devices continued to operate on board the probe. What happened to the second Voyager next? As of November 5th, 2017, the spacecraft was about 116 astronomical units away, or roughly 11 billion miles from Earth, moving at a speed of 9.6 miles per second relative to the Sun in the direction of the Constellation Telescope. If Voyager 2 maintains its current speed, It will take about 19,390 years to travel just 1 light year. Don't you want to know what significant event happened on July 8, 2019? On this day, after receiving a command from the center, Voyager 2 successfully activated its trajectory correction instruments to control the spacecraft going forward. Later, on October 28, 2020, National Aeronautics and Space Administration restored contact with Voyager 2, which was more than 11.6 billion miles away from Earth. Now the probe has found itself beyond the influence of the Sun in interstellar space. By the way, for those who don't know, the original Voyager mission was designed to implement a program called the Grand Tour, which involved a long journey through the planets of the solar system. The ambitious plan of the late 70s was intended for advanced space research vessels designed to study the 5 outer planets, but scientists were forced to partially freeze the project in January 1972, primarily due to unjustified expenses projected at around $1 billion. Instead, it was proposed to launch only 2 spacecraft to Jupiter and Saturn in 1977. Both probes were specifically designed to study the 2 gas giants, and they were better suited for this than their predecessors, Pioneer 10 and 11, launched in 1974. Mission developers proposed that if Voyager 1 succeeded, Voyager 2 could be sent to Uranus and Neptune. This could be done using gravitational maneuvers, which is what eventually happened. Each of the 2 spacecraft was equipped with a color slow-scan television camera to take pictures of celestial bodies and their satellites. The spacecraft also had an extensive set of instruments to record magnetic, atmospheric, satellite, and other data about the planets and their moons. The design of both spacecraft was based on the older Mariner models. Until March 7, 1977, they were known as Mariner 11 and Mariner 12. Then National Aeronautics and Space Administration Administrator James Fletcher announced that they would be renamed Voyagers. But everyone is interested in what Voyager 2 is doing right now. In the dark depths of space, billions of miles from home, National Aeronautics and Space Administration's Voyager 2 spacecraft has become an important link in astronomical research, becoming the second probe ever to enter interstellar space. But of course, such a serious mission did not go without its problematic moments. As of November 2018, National Aeronautics and Space Administration was regularly in contact with the probe, but one day staff couldn't reach it, which greatly surprised them. This was preceded by an unprecedented event that occurred on January 28, 2020. So what happened? Was the spacecraft attacked by aliens, or was it swallowed by a black hole? No, the probe just suddenly froze. Stopping its movement, Voyager 2 came to a halt right before performing its planned maneuver. The spacecraft was supposed to turn 360 degrees to calibrate one of its onboard instruments, but instead it didn't move at all. As a result, both of Voyager's systems were running non-stop, consuming a huge amount of energy. So what was the problem? The problem was that the spacecraft was using up its available power source too quickly, and this triggered the protection system. When it restarted, the software automatically turned off Voyager 2 scientific instruments to save power, since after all, it has a pretty limited supply of resources. The issue had to be fixed quickly as Voyager 2 was moving farther from Earth. Thus, to avoid similar malfunctions and significantly improve communication, a plan to modify the antenna was proposed as a solution to the situation. During the implementation of the project, radio communication with Voyager 2 was completely shut down, and for an entire year at that. It was a risky but necessary task, so the engineers committed fully. Luckily, the probe's year of silence went smoothly, allowing the project to finish successfully and quickly. Contact with Voyager 2 was restored on November 2, 2020 after the spacecraft received a special communication channel. As a result, on February 12, 2021, communication with the probe was fully restored. Now the Voyager 2 mission is active and productive again. The spacecraft continues its interstellar journey, studying the surrounding environment and sending data back to Earth. Although the probe's camera is not powerful enough to produce high-quality images, Voyager 2 is still important for humanity in terms of space exploration. It's the second interstellar object made on Earth, and the only one we contact so often. That is, at the moment, Voyager 2 is the last of the magicians, you could say, a representative of a dying breed. Undoubtedly, one day the moment will come when its power source runs out, and the mission will come to an end, leaving the probe to wander forever in the icy embrace of infinity. Subscribe to the Hubble channel, like the video, and don't forget to share it with your friends. Let them also learn more about the mysteries hidden behind the brilliance of galaxies and the veil of nebulae. Just because you're not paranoid doesn't mean no one is watching you. Modern astronomers don't wait for nature's surprises. They carefully observe activity in and beyond the Milky Way. And have there been any worthy discoveries? It turns out yes. Recently, the instruments detected an unidentified object that was emitting regular radio signals. It's hard to say what it is, but it clearly doesn't want to be detected. Scientists first discovered this astronomical object 2 years ago. This was made possible with one of the most sensitive instruments designed to study the distant corners of galaxies, the antenna arrays in Australia. Remarkably, while working with this radio telescope, scientists repeatedly detected unknown objects and mysterious signals. After these inspiring discoveries, the research continued as more specific information was needed. For their work, the astrophysicists used another device called Marion from the Parkes Observatory. Unfortunately, it did not live up to expectations. No new data was obtained. Progress was made only this year. The South African radio telescope Mir-Karoo Array Telescope confirmed that the object previously discovered does indeed exist, and in April, the Australia Telescope Compact Array instrument also sent in evidence. The unexpected discovery is of great scientific value, because before this, it was practically impossible to get a clearer idea of the mysterious object. It seemed to avoid being observed. Monitoring showed that it simply wasn't present in archives, radio data, or studies based on X-ray or infrared spectrum methods. What do we know about this phenomenon at the moment? It was given the name Galactic Center Radio Transient, J1 745 DFIS 3009. Researchers described the object as a transient radio signal coming from the center of the galaxy. The available astronomical data cannot shed light on the origin and structure of multi-wavelength objects similar to the one discovered. Simply put, this radio signal is unique in its characteristics. Galactic Center Radio Transient J1 745 DFIS 3009 will likely be classified as a new type of cosmic object in the future, and it may not be the only one of its kind. That's because, with more advanced technology, scientists will continue to detect identical radio signals. What's remarkable about Galactic Center Radio Transient J1 745 DFIS 3009? The radio waves it emits are quite unusual. Their duration ranges from 2 to 4 weeks, and after this period, the signal stops. But after some time, it appears again. The phenomenon can be compared to blinking. Circular linear distortions are also noticeable, which means obviously we are dealing with signal polarization. While researching the strange object, the devices detected signals exactly 13 times. At the same time, scientists emphasize that we still cannot determine exactly where these messages are coming from. The only thing known for sure is that it is not a pulsar with the strongest magnetic field. Initially, the theory seemed quite plausible, but further research disproved it. So what exactly are we dealing with? It is known that objects in the universe differ from each other by long radio waves. The stars in some binary systems are located close to each other. If Galactic Center Radio Transient J17453009 were one of these celestial bodies, scientists would have discovered it much earlier. Also, the object cannot belong to supernovae since their properties are completely different. Therefore, the question of classification remains open for now. Space is an unpredictable place, and in recent years, a number of very unusual things have been found there. For example, the Hubble telescope recently took pictures of a region of the nebula called Herbig-Haro, specifically one of its objects, H111. It was captured by cameras sensitive to a wide range of wavelengths. The formation of the Herbig-Haro region was facilitated by young, highly active stars that sometimes emit ionized gases with extremely high temperatures. As a result, atoms lose their electrons and become electrically charged. What happens next? The ionized gas crashes into interstellar clouds made up of other gases and tiny particles. These processes take place near young stars and occur at incredible speeds. What does analyzing the information provide? Thus, scientists were able to find out how the Herbig-Haro object region originated, as well as record phenomena whose lifespan is extremely short, only a couple of thousand years. If you study images of such nebulae closely, you can notice how they move at great speed through gas clouds, moving away from the main star. Significant changes are observed in these areas over several years. For example, in certain locations, the brightness is much higher than in other regions. One of the Hubble telescope's cameras is highly sensitive, so it is able to detect even small waves that are invisible to the naked eye. As you know, there are high brightness objects in Herbig-Haro, but it's difficult to track the processes there because the view is obscured by an impenetrable dusty haze. This is where the wide field camera, 3 camera installed on the Hubble, comes into play, capturing waves that are able to penetrate through layers of dust. Research is ongoing, so it's too soon to draw conclusions. These are far from all the surprises scientists have received in recent years. The cherry on top is the next piece of news that came from the depths of space. In 2019, the first image of the boundaries of a supermassive black hole was obtained by the New Horizons telescope. It is known that the object is located 3 million light years away from us in the giant elliptical galaxy M87. Since the photographs of the black hole were obtained, scientists have become even more active in conducting research. Can we reconstruct the chronology of events? 92 days after the observations began, that very sensational, though rather blurry photo of the black hole was obtained. But these landmark discoveries don't end there. Astronomers were able to obtain an image of the polarized emission of the accretion disk. After carefully studying the data, the researchers gained a clearer understanding of what happens to the magnetic field. The information gathered is far more important than the black hole's image itself. After all, no one has ever gotten this close to it before. This unique data enabled a more detailed examination of the accretion process. Recently, astrophysicists received valuable information from multiple research groups. The information concerned a powerful jet soaring out from the heart of a black hole. Scientists don't fully understand these processes yet, but this helps them make adjustments to existing theories. But let's leave aside the dry scientific theories. What does this information give to the average person? Previously, it was believed that the probability of such a huge active black hole forming near the Milky Way was extremely low, but it still happened. Moreover, near M87 there is a distinct energy jet located along the axis of the black hole's rotation. This forces scientists to ask the question, Do the properties of black holes' magnetic fields differ? Or is it all due to an error caused by optical effects, which in fact turn a destructible flow into something invisible? And that's far from all the amazing discoveries awaiting us as we explore space. Who knows? Maybe right now in a neighboring galaxy, there are phenomena occurring that will radically change human life in the future. We live in an era of active space exploration, but the process is significantly slowed down by the slow pace of progress compared to the increasing cognitive appetites of humanity. Think about the probes ever sent to the planets of the solar system. Which ones come to mind first? The Voyager brothers, Mariner 10 New Horizons. But that's not correct. Today we'll talk about the Galileo spacecraft mission, which became a key milestone in the study of Jupiter. The fearless probe managed to capture a unique collision of a comet with the gas giant and thick ammonia clouds in the poisonous atmosphere of the enormous celestial body. It became the first spacecraft to enter Jupiter's orbit and also spent a long time studying the giant planet and its moons. This isn't a complete list. Completed, but that does not diminish the tremendous contribution the probe made to the advancement of astronomy. When the amazing story of the creation of the spacecraft began, the mentioned project was started by astronomers back in the 1970s. Back then, it was simply called the Jupiter Orbital Probe. At first, the scientists couldn't secure enough funding for the mission, but by using all their connections, the engineers managed to achieve their goal. Time for the initial success. No one could guarantee that the funding for both the project and the laboratory wouldn't be cut off. That's exactly why it took more than 10 years to carry out the mission. Initially, it was planned that the probe would be sent into Jupiter's orbit using the Space Shuttle Columbia, but the idea was never realized due to the prolonged development of the spacecraft. So, the researchers decided to postpone the probe's launch for several years. Again. Because of the Challenger tragedy, the object exploded along with the astronauts on board. 7 people died in the terrible disaster. The world mourned for a long time, but as King Solomon said, everything passes. And so, on October 18th, 1989, the automatic interplanetary station Galileo finally went into outer space with the help of the shuttle Atlantis. First, the spacecraft headed toward Venus to gain additional speed. The probe didn't just fly by, it studied the composition of the clouds surrounding the misty planet. After that, Galileo performed another 2 gravity assists near Earth. Additionally, this helped to obtain more extensive information about asteroids. In the first images taken by Galileo, the asteroid Gaspra was captured, becoming the first such object to be approached so closely by an Earth research spacecraft. And here is an image of the asteroid Ida. It turned out that despite its small size, it has a satellite named Dactyl. Upon closer examination, even craters were discovered. Until that moment, scientists had not recorded the presence of a satellite around the asteroid. What else did the probe manage to do? During the second gravity assist, Galileo also scanned the moon using an ultraviolet spectrometer. This made it possible to better understand the nature of changes in the lunar regolith under the influence of solar radiation. Next, the Galileo orbiter gained enough speed to head straight for Jupiter. What event made the mission successful by default? In 1994, Galileo managed to detect fragments of the Shoemaker-Levy comet, which were about to enter Jupiter's dense atmosphere. Researchers couldn't observe the epic catastrophe live, since the fragments were moving on the side of Jupiter not visible from Earth. Galileo made things easier for scientists and provided the opportunity to observe this event. Later, the collision itself and its aftermath were recorded by the Hubble telescope. Thus, this became the very first observation of a comet meeting the surface of a celestial body. Do you think the amazing discoveries ended there? Of course not. On July the 13th, 1995, the greatest event in the history of space exploration took place. The descent module separated from the orbital module and headed toward Jupiter's poisonous clouds. At that time, Galileo was collecting information about temperature fluctuations, atmospheric components, and the spread of radiation on the gas giant, the last point from the very beginning. Emissions in general. About 60% of the total radiation the spacecraft received in just 1 hour of data collection, while being at a short distance from the planet. But that's not the only problem. Electrostatic discharges also hindered the spacecraft's normal operation. It was impossible to know in advance how great the threat was and how it would affect the probe's operation. Everything was decided only on the spot. So, in December, 1,995 Galilei flew at a very close distance to Jupiter's moon Io, whose gravity helped move the probe into the desired orbit. At the same time, the orbiter received signals from the descent probe, which had entered the atmosphere of the gas giant. In less than an hour, astronomers were able to confirm that the probe was fully operational and capable of collecting data from monitoring Jupiter's atmosphere without any issues. The scientists breathed a sigh of relief as their years of painstaking work had not been in vain. Do you know what happened after this news? There was a loud round of applause. By the way, the number of people working on the mission reached 10,000. So let's not judge the scientists too harshly for showing emotion, because it's completely understandable. Something unprecedented happened. An Earth probe descended into a place where no human-made device had ever gone before. What awaited it in this hellish realm of raging hurricanes and sulfuric rains? When the probe entered the atmospheric of Peter, it reached about 47 kilometers per second. Almost immediately, thanks to the cone-shaped heat shield, the probe began to slow down. Later, a special parachute with a diameter of 2.5 meters helped reduce its speed. The deceleration process significantly heated the surface of the probe. The temperature of the special plasma layer covering the heat shield reached 14,000 degrees Celsius. The aerodynamic forces acting on the small craft were incredibly high. These are record-breaking and, one could say, borderline values for a landing device that has ever entered a planet's atmosphere. Before deploying the parachute, the probe jettisoned the tail fairing and fragments that remained from the heat shield. This happened at a distance of about 18 kilometers from the edge of the cloud layer. For the remainder of the time, the probe continuously collected data about Jupiter's atmosphere and transmitted it to the orbiter. As a result, the probe passed through a layer of the atmosphere that contained small fragments of ice and hydrosulfide, as well as a cluster of clouds that apparently consisted of frozen ammonia. As it turned out, there was not as much water in Jupiter's atmosphere as had been assumed before the mission began. Later, scientists suggested that the probe simply descended in a place where the atmosphere was drier than in other parts of the planet. Such an area is also called a hotspot. Last year, National Aeronautics and Space Administration confirmed this theory based on data from the Juno spacecraft, which began studying Jupiter after Galileo. Most likely, the chemical elements and substances in the atmosphere of the gas giant are not mixed well enough with each other, so their concentration varies depending on the location. How can we evaluate the desperate journey of a fragile Earth probe into Jupiter's atmosphere? Although the voyage was planned as a one-way trip, which meant the probe would perish in Jupiter's clouds, the results of the mission are definitely positive. After all, the information obtained shed light on many previously unknown phenomena. Further research of the gas giant may give us more information about the early periods of the solar system's existence. It is quite possible that Jupiter was actually the first to form, and that it contains particles of dust and gas that were not absorbed by the sun. What other events that happened to Galileo are worth mentioning? During the flight, the probe encountered a phenomenon such as lightning. They are not very common on Jupiter, but their power is immeasurably high. And if you add to that a wind speed of 640 kilometers per hour, you get a rather frightening picture. Jovian lightning is formed under the influence of as yet undiscovered hot regions. The probe also detected an intense radiation belt unknown to modern science. It is located about 50,000 kilometers above the upper layer of clouds. Besides the high radiation level, which far exceeds other belts, scientists also discovered helium ions, the origin of which could not be determined. The probe stopped collecting data after entering a turbulent layer with a temperature of about 153 degrees Celsius and a pressure of more than 20 bar. Most likely, the atmosphere, which consisted mainly of hydrogen and helium, got inside the device, meaning the probe lost its seal. Thus ended the short but fruitful existence of the lander. Meanwhile, the Galileo orbiter moved into a highly elliptical orbit, thus becoming an artificial satellite of Jupiter. In any case, the probe overcame incredible difficulties on its journey, provided valuable data about Jupiter's atmosphere, and forced scientists to refute many established theories. Take a look at the screenshots currently on the screen. This is YouTube statistics. What does it mean? Notice that right now, 57% of this channel's viewers are watching without subscribing. This is the true essence of my message to you. So in order not to miss Hubble from your subscriptions, all you need to do is click on this red button, which looks like this and is located below this video. The law of the universe is simple. It's very important to me. The more viewers there are, the more often they watch and like, the faster a new mega exciting video comes out. Talk to you soon.